the next application is boron in nutrient source tracking studies. So what makes boron really advantageous to use when doing nutrient source tracking is that unlike nitrate, which is undergoing denitrification reactions, which in some, especially remediation projects, is actually a very useful tool, it is subject to some augmentations, right? And this can actually lead to some ambiguity, which can be in most cases rectified by the use of an isotope that is more relatively conservative. So what's useful with boron is that it's not undergoing the same kind of reactions that nitrate is undergoing, and it still has all these discrete signatures of sources. So what we can see here on our left-hand side is that we can use a boron isotope to go ahead and refine our sources and understand, for example, that manure to sewage difference, which can be a really critical point. And also help us to figure out, where are our major boron sources coming from and how does that relate to the nutrients entering our system, right? As we talked about before, boron is, very ubiquitous, but it's also the most common in household cleansers. So that means that when we're looking at things like septic waste and sewage, we can use this as another indicator for the fact that there is indeed like a sewage leak or an overflow or something like that.